Hi, welcome back to another Fix It Scotty video, and in this one I'm going to show you how I built a new electric vehicle charger that I'm going to use to charge both of my electric vehicles. But this charger is a little bit unique in that I built it to resemble a replica visible gas pump like what's in the 1920s that stands over 6.5 feet tall. So stay tuned to see how I built it. So I got the idea that I wanted to create a unique car charger for the outside of my garage, and I was trying to figure out what I wanted to do with it. I looked into maybe making it out of an old phone booth or maybe an old vending machine or something like that. But I kept seeing visible gas pumps in different places that I would go, and I was just intrigued by these things. These are a relic of the late 1920s, maybe early 1930s, and they were just impending giant things. They're like, some of these are about 10 feet tall. And I thought, well, that would be really cool to make a charging station out of one of those. The problem is, to buy one used, they cost thousands of dollars, even in unrestored condition. So for the rest of this video, in detail, I'm going to show you how I built this half-scale replica visible gas pump for around a $250 budget, not including the charger and the electrical pieces, just the visible gas pump itself. Okay, well, I'm standing right here, and I know this shot's a bit far away, but I just want to give you this quick shot just to see, with me in there, what the scale of this so far is. What I've built is the frame or skeleton of the base of the pump for right now, from the floor up. And right now, this platform right here is about 51.5 inches, I believe it is, so just over 4 foot tall, and that will be the top of the base of the pump before we start on the fuel cylinder part of it. So this kind of gives you an idea of the overall scale. All right, so to start, we have the base, and what I chose to use for the base is an old steel tire rim. This was a 14-inch tire rim. I'm not sure what car it came from. Now what I did here was notice that you got this step up, and this kind of gives us a nice stepped flange into our round pillar here. This is a 14-inch wheel rim, and at the middle of the wheel rim, it's actually a 12-inch diameter. So really our base is a 12-inch diameter, but it's fluted out to 14 inches. What I did was I cut this off. So basically the equivalent of right here on the other side, the symmetrical side of the rim, is where I chopped this right off of the top of the rim. Okay, so after I got the base, then what I did was I bought this piece of tube steel. This is 1-inch EMT conduit. You'll buy this at the home improvement store in the electrical section. So notice what I did, because of this larger gap in the wheel rim here, I needed to center it in there. So I put a piece of plate in there and with a hole in it, and I sent it through the hole there and just welded it. It kind of looks gross, but I just welded it up, and that kind of centered it in the base of that wheel there. Now be careful when you're welding on anything galvanized or zinc plated. Zinc fumes are toxic, so if you do have to weld on zinc plated stuff, make sure you hold your breath while you're welding, get plenty of airflow in there, and then walk away and breathe, and then just make sure you're holding your breath when you're welding. Now these are just simply 3/8 rebar. When you're buying rebar, don't just go into the store and buy the pre-cut 48-inch pieces. It's convenient, but they'll cost you about $4 a piece, or about $1 a foot for this stuff. Instead, what I did is I went into my home improvement store that has an outside yard, a contractor area, and I bought the contractor's size 20-foot pieces. I just bought 2 of them. I bought my battery-powered grinder out to the yard with me, and I cut them out there so I could fit them in my car. But I bought 2 20-foot pieces for around $11. They were about $5.50 a piece, or less than $6 a piece. So for under $12, I got all the 3/8 rebar I needed, plus even extra. So that provided a cheap way of putting round rod steel in to make that the framing. Now I'm using this welder here, which is a small 110 volt welder. I've also got an extra stick welder that I haven't really messed with yet, but I just got that for $60, so I might use it on this. But all you need is a small welder. Now, this cannot weld 3/8 thick material. So the way you end up handling it, and I'll give you an example here, is if you have a small welder like mine, notice that this weld here, what I did was I ground down both sides of this rebar to make it as thin as about 1/8 of an inch. And then what I did was I welded it multiple times. So I got really good penetration and burn through on when I thinned out the material. And then you can see there's really good penetration on the wheel rim as well. So that's how you can deal with having thicker material than your welder can do. Now at the top, I can't do that. What I end up doing at the top, and it's not pretty, but you know, you're not going to see it, so it's fine, is you basically just grind these down to like a pencil where it's like a tip coming out. And then again, just weld around that tip. You'll get good penetration into your sheet, and you'll also get decent penetration into your 3/8 material here. So it's nice and sturdy. Now the other material I bought was some 16 gauge sheet metal. So I got that sheet right there, and I cut out a circle of that. Now this circle is at 10 inches. So we have that sheet on, and make sure it's nice and straight. I have a little post level there. I have my 8 rebar pieces just welded on at equal distance all the way around to make it rounded like that. So the next step there is I bought some more of this sheet metal. This is actually 18 gauge, just cold rolled sheet. And I got a piece here that's at least 4 foot on one side. So what I'm going to do next is I'm going to start sheathing in this framing. Okay, a little progress shot here. I got the sheathing going, and as you can see, I've got most of it sheathed except for 2 pieces here. And I wanted to kind of pause before I get those last 2 pieces in to show you how I did the sheathing and where I'm going to go from here. Well, it starts with I made a cardboard template for each of those sections, and I would just put that over the piece of 18 gauge sheet and draw it out and cut it out. Okay, so to apply the panel, basically what I did is I have the panel here. It's a little bit oversized, and I would start at one side, like right here in the middle of the rib, and I'd tack it in the corner. And then what I would do is I would tack it like all the way down every couple inches and just making sure it's straight around that half of that rib. Then I would take my hammer and I'd hammer it at the top, hammer, tack it, hammer, tack it, hammer, tack it, hammer, tack it. And I would do that until this was kind of stitched all around the seam here. And I would do the same thing at the bottom, at the base, and make sure it's all stitched around. But again, in the middle parts, it's going to be fine just to be flat. So what I would do for the middle is once I have it down like this, I would get my pliers and I'd pull it in the middle, and I'd tack it inside. And I'd tack it on the inside all the way, you know, every couple inches to have it pulled down. And then because it was a little bit oversized, I would cut it out halfway down. So notice like here where I did it, I want to expose half of the rib. And so I basically would take my zip cut and slice it about 12 inches, then tack it back in. And again, because I have those tacks on the inside, it's holding it down. I tack it in, slice it, tack it in until I had it all done. And then that's what it should look like. So if you're just building this for your inside man cave or garage, you probably don't need to do what I'm about to discuss. But if you're planning on doing what I'm doing, where I want this outside in the elements, in the rain and snow, I've got to be a little more diligent about how I seal it up. Instead of sealing this up by painstakingly stitch welding it all in, I don't want to put that kind of time into it. So what I'm going to do instead is I'm going to use fiberglass filler on the seams here and then filler over that. But before I do that, on the inside, I want to make sure that's extra sealed. So on the inside, as you can see, on all these ribs that I've tack welded up, I've sanded the metal down and I've degreased it, and I'm going to go over it again with Windex and just basically prep it. If you could see here, obviously it's not sealed up. So what I did was I got some of this seam sealer. Now this actually isn't automotive seam sealer, it's OSI Quad. You can buy this from any hardware store. It's windows and door sealant, and this is made for the exterior of your house. Now this can stick to anything like vinyl, PVC, wood, coated aluminum, brick, concrete. It literally sticks to anything. This is just as good, in my opinion, as any automotive seam sealer. The one problem with this is in the cure time. This takes between 7 and 14 days to actually cure. So an auto body shop couldn't use this as a seam sealer just because of the dry time. But if you're patient, you can save 3 times the cost. These are basically $8 a tube, and get this instead of an automotive seam sealer. Notice that you could see daylight between these gaps here. And like I said, rather than stitch welding it all in, I'm going to seam seal all around the rebar ribs, and do that now while I can kind of fit my caulking gun in there in most places. All right, so we got our seam sealer applied, and I've let it dry for probably 8 days. I took it inside the house, and that's what it looks like. One thing I learned about the seam sealer is that it is a very rubbery type of caulk. In the areas that you can't get the caulking gun, like on the other sides of these seams, you think you can just load it onto your finger and wipe it in, you know, like if you have a gloved finger, just wipe it on there. It does not work. What it does is it pulls away right back onto your finger, and it doesn't stick to the metal. What I found a better way to do it is you just take a soft plastic filler spatula or whatever and just load the caulk onto the end of that, and then you can just basically wipe it onto there, just wipe it into the seam. Just so load it, wipe it, load it, wipe it, and just continue on that way. Then wait a couple minutes, and once it skins up, then you can take your gloved finger and kind of wipe it and move it where you need it to go. And so that's how I was able to get in all those hard to reach areas. Okay, well at this point I got that second to the last panel put in right here. And at this point, I'm on the very last panel of the entire build. Now there's a few considerations we have to make before we box this thing in and make it limited in what we can do and get our hands into. And one of the things I did was, notice I got some cans of spray paint in here, and I used this weld through primer here on the upper, notice that inside here it's gray. I used that weld through primer on the upper part here because I may still be welding onto that. I also used that on this last panel piece here. I painted and let this dry the entire inside of that panel with that weld through primer. For the rest of this stuff, I just painted it gray with this regular, Rust-Oleum primer. It's just a rattle can primer I bought at the hardware store. And then I thought I already had some of this stuff. This is Duplicolor Rocker Guard. It's a thick texture black paint that you use like on the undercarriage of your car or inside the panels and stuff to protect them. And what I did there is I coated kind of the inside of the bottom here up about maybe up 10, 12 inches, and just kind of coated all that. So if there's any moisture in here that kind of falls down to the bottom will be very well protected inside. Also on this second to last panel, I was able to get in here and do the seam sealer. Yeah, I'll have to wait another week for that to dry, and then I'll come back in and finish priming that. Now for the last panel, notice I've put in a couple pieces of rebar right here, these horizontal pieces. So what I'm going to do is make an access panel. And as you can see, I also started thinking through, because, again, this is the time to start thinking through if you're going to do something special with your project here. Like for mine, it's going to be an EV charging station. Therefore, I need electrical stuff in there. So before I put this panel in, I was able to get a bracket in here and just like a 1-inch conduit bracket and drill the hole in the back, spot welded it on, and then I was able to bolt this electrical box onto that conduit bracket. This is an aluminum outdoor grade electrical box. Even though it's going to be inside here, I want everything to act like it's going to get wet. Just to make sure everything's extra safe. It's between these two pieces of rebar here approximately, because I'm going to make a access panel here. So these rebar are going to help me to make it much more stable. Now notice that the top part is actually welded on top of my other rebar, so it pokes out, but the bottom one is actually inset. And the reason I did it that way is so that this is basically plumb right here, if I do that. And so yeah, I'll have to, when I put this panel on here, it'll come out, curve out, and I'll have to like put a little, gussets in here, and fill that in. But this will kind of curve out, and so if water comes down on it, then this panel will be kind of flat and protected. Now I'm also planning on making the hatch weather tight, so there'll be a foam seal around the hatch as well. And I'll show you that later, but I at least have the framing for it in right now. All right, well, I brought you indoors for a change. I kind of just brought it into my house because of how cold it is outside, just to show you the last panel that I put in there. I decided to do it in 3 pieces here. So one piece goes over, had to do some fill-in pieces. You can see how that scoops out a little bit, and then we're gonna scoop, and then we're gonna just put another piece in, and that's gonna go flush and plumb downward. So there it is. While I was working on the pump base, I thought I'd start working and figuring out what I'm going to do for the fuel cylinder part of it. So what I did initially was I took a 12-inch pizza pan that I had in my kitchen. I drew out these 12-inch pieces and I cut 2 of them out in my 16-gauge sheet. I cut 2 of them out, and of course I did it with my grinder, so it wasn't very accurate. And what I did was I placed the 2 pieces of metal on top of each other. I drilled a hole out only in one of them, in the center, and then I plug welded the center plate onto the bottom plate so that they're pretty much stuck together like this. What that allowed me to do is it allowed me to take it to my bench grinder and grind out the edges and make them both exactly the same size. And then I took it over to my drill press and I was able to drill out all of these holes. There's 8 equal distant holes drilled with a 3/8" drill bit, and they're equally spaced all the way around. And then finally, I drilled out the center, which freed the 2 pieces from each other, and then I widened those holes to about 1 inch each. So the idea here is one of these pieces, one of these symmetrical pieces, will be the base plate for the fuel cylinder area. The other one will be welded to whatever my top piece is, and that will be up here. And then I'll show you later, but I've got some threaded rod that'll connect these 2 holes together. So we'll have threaded rods all between those 2 plate holes right there. And then of course we'll have the topper and then the marquee up above. So that's what I've got done on the fuel cylinder area, and I'll show you more about that. But the next time I'll bring you in, I'll have the front hatch welded in, and I'll have this plate welded in, and then we'll go from there. Thought I'd bring you back in for a little progress shot here. And as you can see, I've got the access door kind of welded on, and I have decided that this will be the front of my pump because I think it looks the best. It's probably the straightest side I have. So what I did for the access door, again, I took 16-gauge plate, a full plate, and I welded it top and bottom, and then filled in, the extra little side pieces in here and make sure it was all stitch welded all the way around. Then I took my grinder and I cut out this access hole right here. And then I drilled some holes here and I put some riv nuts in there, and that way I could just bolt in the door. And here's the door. So rather than wasting that piece of metal in there, that's the 16-gauge plate. I plug welded it onto an 18-gauge plate, and that makes a real thick and sturdy door. It also helps with alignment because I can just use that to kind of align it into the hole there. That's pretty much it. Now I will be putting a closed cell foam rubber seal all the way around that for water tightness, and I will be using some rubber washers on the bolts as well to make sure it's watertight. Now I mentioned I won't be using any specialized tools, so if you don't have a riv nut tool, some other options are these things are called jack nuts. Similar to riv nuts, you just drill a hole for it, you pop it in the hole, but you can use an impact driver and a bolt with a nut to cinch it on by just driving in the impact driver, and that pulls it in like a drywall anchor. So that's what's called a jack nut. Another way you could do it is you can use just these like automotive style speed nuts and just kind of drill a hole for it and just put these into it, and your bolt can thread onto that. Or you can weld a nut onto the back or use self-tapping screws. It's whatever you want to do, but that is how I did the access panel. Well, before we can call our base cylinder here completely done, I want to finish off this top plate. In the last clip I mentioned that I created these two plates. They're kind of mirror images of each other. I explained how I did that. I drilled some holes in here and spot welded it to the top. And then I started welding it, all around the perimeter as well. One thing I noticed though is if you look at it dead on, it just seems like it's missing something. It's just a thin piece of metal. And so I wanted to address that. One of the things I found at the store were these, they're called chair braces right there. And basically they're just like these little corner braces that you can put to shore up a chair leg. This is what they look like. And what I thought I would do is use these as gusset plates. So notice that I lined up the holes more or less with the seams. It's not perfect since I eyeballed everything. But what I thought I'd do is take these gussets and just in between, like directly in between the holes, I will put this in there. And basically what I'm going to do is just kind of tack weld it into here and then just kind of stitch it in a little bit. For the hole, what I would do is I'm going to fill this in with weld. But for the top, notice it's a little too long. What I did was I cut the top out and ground this down and kind of pounded it back in and then welded it up. So this is what they look like. I did a few on the back here just so you can see these gussets. And as you can see, I mean, they're not very pretty, but once I get some fiberglass filler in here, that'll look nice and smoothed up and nice. But as you can see, they kind of give that added dimension that I'm looking for. So I'm going to finish welding the rest of those on there, and then we'll be officially done with this base. All right, let's get a progress shot here because I got the fuel cylinder area starting to take shape, and let me show you what I did to make it look like this. So to start, I got some threaded rod, and originally I bought these for my electric car project. These are 6-foot 3/8" threaded rod that I bought from Zorro. Well, I needed 12-inch sections or under for the electric car battery project, but I realized that these are actually left-hand threaded, and I did not want that for my battery tie down, so I ended up finding some 12-inch by 3/8 carriage bolts, and I used those instead. So I had this stuff left over, and this is a perfect project to use it on. So what I decided to do is make my fuel cylinder area 16 inches tall. So I measured from the base here and up to the top 16 inches, and I cut off the pipe again. Then what I did was I bought this box coupler. Since I drilled a 1-inch hole out, I could just mount it to my top plate here, and that's what allows it to just sit on the center right there. Well, then what I did was I took my 18-inch sections of this 3/8" threaded rod, and I bolted it to the top and bottom of my bottom flange, which again, my bottom flange is all pretty much flattened. And of course, like I did last time, I got all my gussets put in. So this is nice and flat. And so now my threaded rods are in there. I put the plate on and attached it to the middle and just dropped it on to these nuts that I already had threaded down onto it. Then I put nuts on the top. Now I have nuts on either side. Well, because this plate is still a little bit warped and, wobbly, it was even worse before. But what I did was I took my ruler and I measured from the base to the plate here, and I got different measurements all over the place. It's all warped. So what I did was I made sure, if it was too high, I would run down this nut and lower it. Or if it was too low, I'd run up the bottom nut and raise it a little bit. And I went around to each one and made sure they were all exactly the same measurement. And that way I know at least on the outer edges, the plate is all matches up. So now that gives me the perfect opportunity to weld on the top cap. But what am I going to use for the top cap? Well, in the spirit of this project, I'm going to use a junk hubcap. These are my VW hubcaps for my bus This one was rejected because it's quite beat up and scratched up, and the chrome is in pretty bad shape. So what I'm going to do is going to clean this up, and I think I'm just going to weld this onto the center of this plate. I'm probably just going to clamp it right down and get a ladder and actually weld it while it's all connected here, so that if I put too much heat in, I limit the amount of warpage I have. But I think that looks pretty good. Yeah, it's not as bowl-shaped as some of the ones I've seen. It's a little bit shallow, but I think it looks pretty good. And imagine if I cut off all these excess stems here, what that will look like. So let's back up and kind of see. And I think it looks pretty decent. So that's the next step there, is to get that topper welded on to that plate. All right, bring it back in, showing you the progress here. Got my studs cut down, and I took the nuts off because I'm going to take this off. But there it is, welded up. That's good enough for our fiberglass filler. And if we back up, we can get a shot of the whole thing. It's starting to come together. We went from looking like an outdoor patio gas heater to a lighthouse, but still I like it and I'm still having fun, so we'll go with that. Well, the next thing we want to do is to finish this fuel cylinder part out, is we actually want to build this fuel cylinder. Now, of course, I'm not going to build this out of glass, but what I thought I'd do is, many of these back in the day had this metal grating that covered the glass area to protect it from rocks and road debris. Remember back when these were in service in the late 20s and early 30s, there would have been mostly dirt and gravel roads back then, so they had to protect that glass cylinder from breaking. And what material we're going to use for that is called expanded sheet or expanded steel, and it's basically like a grating material that you can buy. It comes in different dimensions depending on how you buy it. I happen to get this on eBay, but I'll provide a link to an Amazon thing that has it. You want the 13 gauge, something around there, because that's about the thickness we want. The 3/4 1/2 inch spec on this refers to the gapping in the metal grating. I would have preferred actually the 1/2 inch, the smaller gapping, but I got a good deal on this stuff on eBay, so I went with the 3/4 inch. So the problem with this is it's flat, and I need it into a round cylinder shape because I want to put it inside, just inside of here. So I bought this at the store. This is a plant stand, and it has these 10-inch rings. It stands 14 inches tall, but those steel arms are obviously longer than that. The idea was I'd harvest it for steel since it was only 10 bucks. We've got two nice round 10-inch rings. I'll cut those off, and then we'll just reconfigure it to where there's a ring at the top, a ring at the bottom, and then those 3 uprights welded together to make kind of the cylinder again. I'll bring you back in once I show you some progress on that. All right, where I got all the extra metal cut off that little planter stand, and that's what it looks like. It's basically just the 2 rings with the rods connecting them, and that's going to be the right height for my cylinder area. Now, as you can imagine, what I'm going to do here is take my little frame structure and I'll lay it down onto my expanded sheet. And I think probably what I'll do is lay it right here and then just tack it near the rib right here. Just tack it right here, then tack it, and do it on the other side. Tack it, and then roll, tack, tack. On the other side too, tack, tack, roll, tack, tack, roll, tack, tack. You get the idea. So obviously what I'm trying to do is wrap that expanded steel around my frame, and then I'll cut it to size. But unfortunately, I committed the cardinal sin of welding, which is to run out of shielding gas on a Saturday, and none of my supply stores are open on the weekend. So we'll have to put that off until the week, but I'll bring it back in to show you some of the progress. Our shielding gas is refilled. We're ready to move on. Now, before I start welding this, like I suggested, what I did was I took my 2 screens, and the problem with these screens is they're always kind of sold in this type of dimension where it's skinnier than taller, and I wanted to look upright, so I took my 2 screens that I bought and I just welded them together. All you have to really do is just put 1 tack on each of these and then grind it off, and then it's pretty much together. When you're sizing up how much screen to buy, Obviously buy as much as you can so you only have to do one piece rather than two pieces like I did. But otherwise, if it's a 10-inch diameter, the way to calculate it obviously is to do the circumference. You need this long of screen for a 10-inch diameter is 10 times pi, which is 10 times 3.14, which is 31.4, or about 31.5 inches. So these two 16-inch screens is about 32 inches. That should cover it. Now, I might be a little bit off, like maybe I'm like 10 and an eighth or something. So, you know, it's going to be real tight, but hopefully I've got enough. So 32 inches all the way across. So let's go ahead and start welding. And like I said, I'm going to start with the rib on one side. And what should happen is as I work my way all the way around, I should end up on the same side and I should be able to seam it all together. If it's a little bit shy, then what I'll do is probably just add a strip of metal to it. You know, I'll just make sure I oriented that piece in the back. And if it's overlapped, I'll just kind of take my grinder and just cut it out and then just and then stitch weld it back together. So I'll bring you back in when that's done. All right, well, we got the grating welded on and I dropped it down into the fuel cylinder area here. And as you can see, it looks pretty decent. I mean, did it go perfectly? No. Did I blow through a few welds here? I got to reconnect that one. I blew through some of the wire and had to reconnect that. Didn't go perfect. It's not completely straight, but for a folk art project, I say it's passable. And as you can see, I just welded all along the ribs here. But yeah, we'll go with that. I was originally thinking I was going to have to do some bracketry to hold it in place. But once I put the nuts on the top here, it presses down on it. It's in there real tight, so I don't think I'll have to do any kind of bracketry or anything to keep it centered and in place there. So let me back up here and give you a wide shot of the entire pump. So we are now completely done with both the base, the fuel cylinder area, and now we're ready to start on the last and final piece of the fabrication, and that is the marquee. So let's look at how we're going to do that. Okay, so now for the marquee, I'm trying to get a little more creative with this because they do sell reproduction marquees on eBay, and usually they consist of three pieces. You have lenses, those parabolic shaped plastic lenses. You have a bezel for the lenses to go around, and then you have a like cup style holder for that bezel that holds it together. And when you add up those three pieces, they end up costing a lot of money, sometimes hundreds of dollars, which would double our budget here. So we don't want to do that. I've also seen folk art versions of what I've built here. They're not as well made, they're smaller and only for indoor use. But what I've seen them do is take like a round piece of metal and basically heat it up and hammer it over a bowling ball, what it looks like, and make it into like a parabolic dish like this. Well, here's another one of my Volkswagen hubcaps. So this is an example of what I've seen on some of these folk art things. So again, I can make this for free by taking another one of my hubcaps, and really what they were doing, they just simply welded it to the top post and made it look like this. And that's pretty nice. I mean, I think that's pretty acceptable. The only problem with this is I've got automatically have this Volkswagen branding, which I wasn't necessarily intending to do, although I do like Volkswagens. Also, it's a one-sided piece, which is probably fine because I'm going to probably back mine up against the garage and you won't be walking around the other side. So that's fine too, because the other side doesn't look that good. But then the other problem is I kind of wanted to put some lighting into it, maybe light it up and make it real cool like that. So I had another idea for how I wanted to do it. So I was browsing Facebook Marketplace and I found this thing right here. And this is I took the clock out of it, but this is a clock. I'll show you a picture of what I originally bought. But it's like this metal round clock, and it's made to look like, I don't know, like a nautical compass or maybe one of those little binocular coin-operated lookout things. I don't know. So it's on this stand. It's got a kind of pivots and all that. Well, like I said, I took the clock and I took the glass out of it too. And what I thought I could do is just frost the glass, which I've already done. I had some frosting film, And when I put it back in, this will be kind of obfuscated. And notice I've also kind of tested it out. I don't know if you can see this, but I put some LED lighting strip in there. And I'll of course remove this when I go to paint it. But what I think I could do is light this up with that LED strip, and with this glass and the obfuscation, it'll kind of just glow, and I can also put a decal over it. I think that'll look pretty cool. But I can't really use this stand. I don't think that'll work. So I think what I'm going to do, so if I take it out of the stand, I've got this little top piece here, this handle piece, and I thought, well, maybe I can just flip it upside down and weld it to that. But when I held it up there, it doesn't look that great to be lifted up there. So what I think I'm going to do is I've got this little piece of 1/2-inch EMT conduit scrap. What I'll probably do is cut this handle off here, and basically turn it on its side so it's like this. Then what I'll do is just drill out the bottom here and open that up, and maybe just mount it to this piece of tubing. All right, quick little progress shot here on the marquee. I've got my topper up on the bench here, and what I've done thus far is I cut out a 3-inch circle out of my 16 gauge plate, and then I just welded it over, basically over that VW emblem there. But now that beefs it up nice and sturdy, so we got the 16 gauge metal here. Then I drilled a little over a 1/2-inch hole right in the center there. On my caulk thing, I sandblasted it and wire wheeled it, as you can see, so now there's no more paint on the outside. So then I drilled a 1/2-inch hole in the side of this thing and ran my 1/2-inch EMT conduit tube into there, and I carefully welded it on. This is really cheap Chinese pot metal right here, so I had to be real careful. It was blowing holes through it, but I managed to get that on there pretty solid. And now what I'm going to do is send that through the hole here, but I've got these 2 nuts. These are pretty tall nuts, and I'm going to put them on either side of the hole. I'll probably go ahead and take this back to the pump and put it on there. That way I know, since I'm welding it up, I can't really change the positioning once I finish welding it. So I'm going to take it there and make sure that it works. But those nuts will give me a little bit of height to stand it up right down there, and that'll allow me enough height to get my welder tip in there and buzz that in. I'll put a couple tacks on it while it's up on the pump, and then I'll take the whole thing off, take it back here to the bench, and then finish welding it all back up. Well, we got it done. There it is. It's the marquee. Just kind of weld it into there. Let me get a full shot. Our total size of the pump is now well over 6 foot tall, maybe 6'4". I'll get a final measurement to you at the end. So we're officially done with fabrication, minus maybe a few touch-up welds. So now what I'm doing is I'm retooling, because the next phase here is for us to do all the body work and paint on it. Okay, so the next step will be the filler work and the priming. And I wanted to use products that I already had, because this is probably about 1.5 years old, so I need to use it or lose it. I've got about enough left in this can to maybe mix up about 1 quart. But this is epoxy primer. Now, epoxy primer is a little bit different than a standard automotive urethane primer. Epoxy primer is best to go over the bare metal, and then you can do your filler work over that. If you have a high build primer or urethane primer, you want to do your filler work first, sand and prep it, and then do your primer. But because I have this epoxy primer, I want to use it, I'm going to do this first. But whether you do your filler or your primer first, either way, you've got to prep the metal. And in both cases, you prep the metal by sanding it to about 80 grit. So let me show you what I've been doing to prep our metal for the next step. So coming over here, we've got a bunch of tools laid out. I've got my little 5-inch DA. I've got a bunch of 100 grit sanding pads for that. I've got my little finger sander, a little 1/2-inch belt sander, and I've got my wire wheel, and I've got a flap disc. And I've basically just been going over everything. I've got rid of all the coatings, all rust that was down here before. Nice fine surface scratches. I sanded over all the metal. With the flap disc, I went over the welds again, And with that little finger sander, just getting into here, just doing some detail sanding and getting it all ready. I've also been sanding my other pieces. I've got everything taken apart. So the next step is to clean everything. You could use a paint prep solvent, but I don't want to spend the kind of money on that. So usually what I do is use this ZEP degreaser, degrease everything. Then I finish it with a couple rounds of Windex or glass cleaner. And that usually does the job and gets everything clean and ready for paint. And we have our paint booth set up. I just transformed my little workshop in a few minutes, just hanging up some tarps. And if you guys seen my videos before, I've got just a box fan pointed out the window with a furnace filter over it, and there's my exhaust. Apologies for the background noise, but I've got some artificial heat coming into here. This is one of those rare days in early March, northern Illinois here, where we have a nice warm day, and I'm going to take full advantage of it by trying to get this space heated up and maintain that heat and get stuff painted. So for this primer, it's really easy to use. We mix it 1-to-1, and I put it in a gun with a 1.7 tip, and I will just shoot it on. It takes a little bit longer to cure, so the flash time is between 30 minutes and an hour rather than like 15 minutes. So that kind of stinks, but I'm gonna try to get 2 full coats out of this, whatever I have left here, and bring you in when that's done. So obviously the next phase of our project here is to do the body work on it. And here are some products that I have. It's all Bondo brand just because it's cheap stuff and I can find it locally. Good enough for this project. So we have this fiberglass filler. Then I also have a little bit of liquid resin. This is fiberglass resin. Sometimes what I'll do is if this gets a little too thick, I'll put a little bit of this in before the hardener and mix it up really well and get the consistency I want with the resin, because this is basically like maple syrup consistency. And then once I'm ready to do the hardener, I'll put some drops of the fiberglass resin in as well as the filler hardener in, and it makes a nice rock hard finish. So then we've got a regular Bondo filler. I already had this quart here. Hopefully this is enough, but I'll probably have to get more. I've got some Rust-Oleum, just primer, you know, just an automotive kind of primer spray paint. I've got 120 grit paper, 80 grit paper, got some acetone and a spatula and a filler mixing board. And of course here is what we're working on. And as you can see, the epoxy primer is applied and it's well over a week, maybe even 2 weeks. So it's well cured, and as you can see, I've got all that stuff to work out and fill, as well as all the lines. Okay, so before we apply it, we want to do a little bit of surface prep here. So what I did was I sanded it to 120 grit, just like you would do kind of sanding the metal to put scratches in it so the filler has something to grab onto. We do the same thing, and then of course whenever you sand something, you got to clean it. So usually a Windex and a lint-free cloth, just wiped everything down so it's nice and clean. And I'm gonna start at the problem sections. Again, the fiberglass filler is only really for our welds. And so, you know, I'm really just gonna focus on just getting it jammed into our welds here. And then when we do our regular body filler over that, that will smooth out anything beyond what's over the welds. All right, I think my toast is buttered here. I slathered that stuff on, especially all around these things. It is just all over there. So now I'm gonna grab my DA. I've got my 6-inch air DA. Got some 80 grit, 100 grit, and of course my little 1/2-inch sander with some 80 grit belts. And just gonna go all over it, especially a lot of work up there. And you know, just shape all the fiberglass and get it ready for the next step. All right, we got our fiberglass sanded up. There's gonna be some spots where we burn through the epoxy, but that's okay because we'll be doing a final seal coat of primer after this. But the next step is the filler, so let's go ahead and mix some up. Okay, well we got our filler applied, and notice you can't see any more white or fiberglass anymore. I have completely coated this thing with a thin layer of filler. My philosophy on how I do filler has changed a little bit. What I used to do, and again, I've been conditioned like a lot of people when you see restoration videos where people break down a car and they'll show, oh, look at that hack job, look at all that filler, look at all that Bondo. And so I was conditioned to be like, okay, well, when I apply filler, I should apply it very sparingly and just apply a little bit to an area and then sand it down. What ended up happening was I'd apply a little bit, I'd sand it, I'd do a guide coat or primer, and I'd find it's not that great, so I apply a little more to a different area, sand it, apply the guide coat or primer, and then realize it's not great, and then keep rinsing and repeating. Now I'd eventually get to a good place, but it would take me so long. So that's why my philosophy on filler has changed. Obviously, I still think it's a hack to use too much filler. And when I mean too much, I mean too thick of filler. In other words, instead of doing body work and like pulling out a dent, you just slap a real thick layer of filler on the dent in order to make it match up. It's also hacky to use filler to bridge holes. Filler is not structural, so that's obviously a hack too. What you'd want to do is replace the hole with metal, or at the very least, some fiberglass with a cloth backing, and then do the filler over that. But what's not hacky is to apply a thin layer of filler to the entire piece, with the goal there being that you're going to sand most of it off. Yes, it wastes a little bit of filler, but it saves a lot of time because you could pretty much get all your filler work done on one try. And there's the finished sanding. As you can see, some places I burned down to the fiberglass, some cases I burned down to the primer, and some cases I burned down all the way through to the metal. But overall, we have mostly still coverage of the filler, and as soon as I do see metal, I stop sanding. And in order to see how well we did on our body work, I'm going to go ahead and do a coat of primer on this, maybe 2 coats out of just this Rust-Oleum rattle cam primer. And once I clean up and prime it, I'll bring you back in. All right, here it is primed up. If you're an auto body guy, you would know that this would probably be the time where you'd want to use the high build primer and do a final sanding of it. I'm not going to go that far. As you can see, I'm just going to leave the little puck marks, little scratches and imperfections. I'm just going to leave that alone. So the next step obviously is the paint, and what I'm going to do is I'm going to buff the primer out to 400 grit with this paper. Then I'll clean it all up. I'll do a final tack cloth of it. And I'm going to shoot this Tamco single stage paint. This is the same stuff that I shot my bus with. It's that white color. And hopefully I have enough, but the only reason I'm using this is because I do have it, and I have quite a bit in this quart. So I'm going to shoot 2 coats of that. This is going to be a 4-1 mixture, and I'm going to probably add a whole nother part of reducer just because every time I've shot it in the past, it's been orange peely and dry. So I'm going to reduce it down a little bit. And I'm going to shoot it with this 1.3 tip. This is an HTE gun. So I'll bring you back in when that's done. All right, where I got the initial white paint applied, and I've already masked it off because I'm getting ready for the next color. But I will say, and I'll show you at the end, it does look really good. In fact, I'm almost annoyed by how well I shot it. It's nice and smooth and glassy, and I didn't even shoot my car that well. This is probably, I probably shot this white paint a half dozen times, and this is the best result I've gotten. That said, I didn't get the best results on this guy right there, so I'll have to wet sand that. I might actually have to shoot it again. But let me talk about the color scheme here. So the plan here is to do a 3-color scheme here. Obviously the first color, white, then we're going to go with burgundy, and then this steel color. I'm going to do the rest of it with this rattle cam paint, and you might say, oh, well, that's not going to last as long as a good automotive paint. Well, the problem is that most people don't know how to spray paint stuff. Most people just give their piece a quick wipe down, and then they'll just go shh, and they're done deal. But if you apply the same concepts of how we do surface prep and how we paint with nice even overlapping strokes, flash time of 15 minutes, and then a second coat, nice overlapping strokes. If you do all that work and the prep work like you would with an automotive piece, you can get good results out of a rattle can. So burgundy, we're going to shoot from this line that I taped off here and up to this base here. I'm going to do all the top. Everything that's not taped off right now is what I'm going to do with the burgundy. And then correspondingly, I'm going to shoot the topper here. Now this topper I did with the white paint, and I've got to wet sand it because it's pretty orange peely. But I'm going to resand the base down, and that'll be burgundy as well, the base of this top plate here. So we'll have burgundy at the all up and around the fuel cylinder area. And then the third color will be this steel color, this Rust-Oleum dark steel. It's a metallic paint here. And that will be on the fuel cylinder cage area to make it look like metal again. To protect that all, I'm going to use this product right here, and I'll have a link in the video description to this. And you might be saying, oh, okay, well this is just another rattle can clear coat, like a clear lacquer. That won't last long. No, actually this is a professional grade clear coat. It's a two-part. Well, how this works is you got this little cap on it, and notice there's this little pin coming out of the bottom of the can. What you do is you'll take this cap, stick it over the pin, and slam it down onto the desk. That'll rupture an internal seal and actually mix this as a two-part clear coat with the activator. So this is an actual good automotive grade clear coat paint. The only downside to this is once you rupture the activator inside, you have to use it. You can't just set it on your shelf and use it later. But what I plan on doing is shooting all this with maybe 2 to 3 coats of this clear coat on all of these pieces that I'm spray painting here. So I'll bring you back in and show you the reveal of the paint job once I'm finished. All right, well here it is after the paint and reassembly. And I also did a bunch more work off camera without you guys. I apologize for that, but I'll just kind of take you through what I did, and we'll see the end result here, which I'm pretty proud of. First off, as you can see, I've got this, I taped off this area like I mentioned. I painted this, a couple coats of the red, and then clear coated from here all the way up. So you can see I've got this painted separately, and clear coated everything from here up. And so everything looks really good and protected. So notice also I put this black stripe in there, and I think that really makes that paint line look a lot better. That's just a piece of 1/4 inch pinstriping and some black pinstriping I bought for like $5 at the auto parts store. And that makes the line nice and crisp, and it also blends in to the black hardware. And as you can see, I've got the entire assembly of the charging station put together. What I actually had to do was, in the output cord here, I actually had to take apart the case and desolder the cable, the multi-core cable from the actual circuit board there. On a more expensive unit, I'm sure those cables are bolted on, but this cheap unit, they're soldered on. So I had to desolder those cables out of the board, and that way, that freed up that cable from here. I was able to run it through this 90-degree gland nut, which I already happen to have. It looks perfect for this application. It kind of looks like a gas hose 90-degree elbow. Then it goes into there and up into this gland nut here, and then up into the charger. The input cord is the one coming from the top that goes through the gland nut in the back there. It's a little bit smaller one, and that goes down into, obviously, the pedestal there and joins into our junction box that I showed you before that's inside of here. So that's all the charging stuff. The other thing I did was I found this really cool thing on Amazon. I'll provide a link to it if you're interested in it. But it's not only a charging gun holder, this black thing, but it also has a little bit of a plastic piece here that provides you with a little bit of a hose wrap there. But otherwise, it keeps the gun safe and clean and protected there. And then I added a few decals. I bought a pair of these decals on Amazon. I'll provide a link to that. And that's where I got the burgundy color that I matched the paint to. And notice I also have one on the marquee, which looks really cool up there. So on the marquee, let me show you a little bit about how I wired that up. So the marquee, if you recall, was this clock thing, this metal clock, and it had this rear opening lid to it. So I kept that kind of the way it is, just painted the inside of it. And what I ended up doing was it already had a piece of glass, and the clock went in there in this plastic frame. I cut the clock out, but I left the edge of the plastic frame so I can use those little clips to hold the glass in with that plastic frame. I frosted the inside of the glass. You can buy this frosting film that's like window tint film, and I already had a bunch of it left over from another window tinting job. So I just frosted the inside, and that's what makes it kind of still transparent so that you could see the light glowing, but you can't see into it. And then of course I glued that LED strip. Notice there's this black stuff everywhere. That's just some adhesive that I used to glue that LED strip in all the way around there. And again, it plugs in right here. Now this cable right here goes all the way up through the tube that I welded into there, which that tube goes all the way down, and I drilled a hole in the tube around the electrical box there. What I ended up doing there was I found a AC-DC adapter in my stash of parts, and this AC adapter could take as input 110 or 220, in which this thing actually is wired to 220, and I'll show you that in a minute. And it can convert that to 12 volts DC, and that 12 volts DC is exactly what that little LED strip uses. So all of that is inside of that little box there. And finally, what I did in the back is I put this little liquid tight coupling in there, because in the end I'm going to hardwire this to my house. For now what I have is just a 12 gauge extension cord. It's a heavy duty 20 amp extension cord, and I just have a NEMA 620 plug onto it, and correspondingly I have an extension cord that's wired into my 220 circuit that I can test on. Eventually, like I said, when I hardwire it in the house, I'll probably just run this extension cord right through the liquid tight conduit, because it's really high quality 12 gauge stranded wiring. So yeah, let me plug it in. I'll show you it light up. So if you're not already subscribed to my channel, go ahead and do that. I probably will do a follow-up video on this where I install this on the outside of my house, show you all the things that I need to do to get it secured to the ground and wired into the house. So that'll be in a follow-up video, but that's it for this video. And thanks for staying till the end, and hope you enjoyed it. Till next time, I'll talk to you later.